we're continuing our efforts, which are now about 12 years along, to develop perennial sorghum for the U.S. Central Plains. This involves gradually disentangling the perenniality genes that come from the wild perennial parent, sorghum halopense, a wild relative of sorghum, from the genes from sorghum halopense that we don't want, which are numerous. There are many genes influencing development of rhizomes. Rhizomes are the underground stems that allow sorghum to survive the winter and be perennial, things that look like this. And that's what that's pretty much all we want from the wild perennial parent, although there could be other stress tolerance and so forth. But we're trying to disentangle those from genes for small seeds or numerous small wispy heads or towering height or other traits that are not at all what we want in a crop plant. Our current project with the University of Georgia, examining the genomics of perenniality and other traits, and of which Fiona will be discussing next, and of which she'll show you the physical reality in the field later, that will help us separate the good genes from the bad and the ugly, but it will also mean continuing to make a lot of interspecific crosses and growing large populations in the field. Plants that are winter hardy in Kansas at this point still continue to be on the wilder looking side, but we're obtaining more and more plants that produce rhizomes and are better, act like more productive crop plants, but they don't survive the winter. But we're not throwing such seeds away, because even if they can't survive Kansas winters, they may be useful in places with warmer winters, or especially in tropical climates. And so we're working with fellow researchers, growing our populations not only in the southern U.S., Texas, Alabama, Georgia, but also now in sub-Saharan Africa. There are two reasons for this. One, as I said, in a tropical environment, any rhizomatous sorghum plant is potentially perennial, because these rhizomes don't have to go so deep or be so cold tolerant to survive the winter. And also, annual sorghum was domesticated 8,000 years ago in what is today South Sudan, and it's one of the top staple grains throughout much of the continent. Now, about sorghum itself, it was for far too long the Rodney Dangerfield of grain crops, not generally held in the highest esteem. Part of the problem was that it was viewed as low yielding, even though this was not inherent to sorghum. In fact, it can produce tremendous yields, but more because it was usually grown in low-yielding environments, lower yielding than, say, where corn is grown. That's because sorghum has excellent stress tolerance. In Africa, as well as in America, it has tended to be grown on poorer land by poorer farmers. Now, however, sorghum, it's gotten a little more respect. But this is for sometimes dubious reasons. For example, in America, where it had been used almost exclusively as a livestock feed, it is in recent years being used as a more drought-tolerant alternative to corn for making fuel ethanol, which we're not exactly proud of. And it's finding it's a big market in the $4 billion processed food industry that has grown up around the recent anti-wheat craze. But a more compelling reason for sorghum's newfound respectability is that with seemingly everyone involved in international food security being focused on sub-Saharan Africa, people are realizing that sorghum is a hugely important crop in that continent. This is all happening at the same time we've been sending seed of our populations to colleagues in Mali and Uganda, and are looking forward to doing the same in Ethiopia and Republic of South Africa. The initial efforts will be to screen lines for adaptation. That's because the one thing you can always count on in plant breeding is that if you take a good variety or breeding line from one part of the world and grow it in another, it's going to do worse. Sometimes a lot worse, sometimes just a little worse, but there'll always be adaptation problems. That means if any of our lines do behave reasonably well, the first thing our colleagues in Africa will want to do is interpollinate them with their own locally adapted germplasm. Lest you worry that this time that this is going to be some kind of imperialist adventure like those far too many cases in which researchers from the global north have foisted Midwestern or European germplasm and technologies onto people who don't want or need them, well, trust us, it's not. We're cooperating with plant breeders in Africa who are interested in development of more ecologically sound agriculture, and if they examine our germplasm and like what they see, they're going to know how to take it from there. Our goals are simple: to offer germplasm that can, in the hands of breeders and ecologists, make it possible to design new tropical agricultural ecosystems that will halt soil degradation and produce nutritious grain while reducing the need for purchased inputs. And be assured that as we help get perennial sorghum research work going back in sorghum's African homeland, we'll still be putting more effort than ever on perennial sorghum for the Great Plains. Thanks.